Hi everyone, welcome to the session. This is Naveen and I'll be your instructor for generative AI. So as part of our advanced machine learning and generative AI course, I'll be leading you through this fascinating domain of generative AI. So today we are going to start this generative AI syllabus with deep learning concept. So let me share my screen and take you through this concept. Yeah. So deep learning. You would have heard this word deep learning, but you wouldn't be knowing what this deep learning exactly. So before we go deeper into this concept, let me just explain you the AI ecosystem first, and then explain deep learning in detail. Okay. So as you can see here, this is the ecosystem of artificial intelligence, and artificial intelligence here is a broader field, and all the other machine learning, deep learning, and generative AI are just subfields of it, right? So if I ask you what this artificial intelligence mean, you already know about that because we are using this daily. We are habituated to using artificial intelligence daily in our either job related works or personal works, etc. So just to define that, artificial intelligence is any technique that enables machines to mimic human intelligence or perform tasks in a smart way, whether it may be decision making or language understanding or whatever it may be. So, in fact, it is not only mimicking the human intelligence but also exceeding, as you have seen its progress in many fields nowadays, right? So, that is what artificial intelligence means. And coming to this machine learning is a broader field, subfield, we can say, of artificial intelligence, right? So what it will do is it allows machines to learn from data, identify patterns, and make decisions with minimal human intervention. So earlier, let's say during 1970s or 80s, what was happening is we were hard coding every rule, whether it is a software related work or any kind of machine related work, we were hard coding it. But now the technology has been sophisticated, and then we are seeing the machines are learning by themselves by identify the patterns between the data, and then they we are not strictly hard coding everything, right? So machine learning is that field which has given the machines ability to understand the data, learn from it, and identify patterns to it, and work independently. Okay. And then we are coming to the deep learning. So this is what we are going to discuss today. But at this point, I can say a branch of artificial intelligence, and it uses multi-layered neural networks that discover complex patterns automatically. Okay, all these things we'll learn. But here, the deep learning tells us about using neural networks and solving many problems. It might be chatbot creation, or it might be any kind of algorithm, right? So it learns the concept and then it applies by its own, right? That is what deep learning is meant by. And coming to generative AI, which is a buzzword nowadays, and everywhere we see generative AI is gonna boom from 2025, or it all started in 2024 actually. If I ask you what this generative AI can do, you might say it is used for creating new content, correct? New content, maybe it is a text, images, audio, or even video. So if you have that in your mind, you are correct. So generative AI is all about that, but we have a detailed definition for it, and we are going to discuss it later. For now, you can just mark this in your mind. And on the right side, you can see Geoffrey Everest Hinton. So you might not be knowing this person if you are a fresher to this field or a new beginner of artificial intelligence. So he is called as the godfather of artificial intelligence, and he has been awarded Nobel Prize in physics lately in 2024 maybe. Okay, so yeah, and now mind. So it was in 1940s where two of the researchers or scientists you can call. So they got a sparkling idea, which was about how can we create a machine that can learn exactly like a human brain, right? Whatever the process that our brain is taking up to learn things and apply it accordingly. So in the same way they wanted to create a machine. So they just thought like a machine can do this or not. Okay, that was the first idea that they got. Okay, then they proposed this artificial neural network concept during 1940s. Now, to keep it simple, deep learning is nothing but creating an algorithm or a neural network which learns things exactly like a human brain. It may be image recognition or generating the voice or generating the text or studying the medical scans like X-ray, CT scan or whatever. So all these applications, so the deep learning neural network will learn and understand the patterns and can gain a deeper understanding on it. So let me take you to the history of neural networks now. As I said earlier, this all started in 1940s, where two of the researchers or the research scientists they proposed a artificial neural network which can mimic just like a human brain. So they created a single artificial neural network, and then you see the years here. These are the significant contributions that were done in the domain of artificial intelligence. Okay, I'm not going to discuss all these. As you can see, each and every year here has some very good contribution towards artificial intelligence, and at the end you will be surprised by this fact. Okay, so this happened in 2016 where artificial neural network defeated world champion in the game of Go. So if you don't know what this game of Go, it looks like a chess game, but it is a little bit difficult than chess. Okay, as you know, chess involves multiple permutations and combinations, right? And this game of Go also involves the same, but in a larger scale. Okay, so in 2016, this algorithm, AlphaGo algorithm, which was developed by Google, it defeated the world champion. So it was historic because uh, Go was thought to be too complex for artificial intelligence. But the interesting fact here is AlphaGo did not memorize moves. It learned how to play by practicing just like humans do. And this is the essence of deep learning. The neural networks, they won't memorize anything, but they just learn how to do things and then implement them sequentially. Okay? Yeah. Now let me take you to the next slide. Yeah, by now, as I said, this neural networks and the other concepts of deep learning. So you might be wondering where this deep learning is being used nowadays, right? So deep learning we have been using from a couple of years. You know, you'll be surprised the chatbots you are using, or when you use Facebook, you will find auto tagging option where it automatically auto tags your friends. And not only that, you have voice assistants like Gemini Live or Chat GPT or whatever the voice assistants we have. So they are all the applications of deep learning. Okay, these applications are not limited to whatever I have said. So it extended more than that to a medical studies as well, like studies on X-rays, MRIs or CT scans. They are all now dependent on deep learning. So by this point you would have understood how much important is this concept for artificial intelligence to grow further, right? Okay, now the actual definition of deep learning has come up. Let me just read whatever the definition we have here. Okay. So deep learning is a subset of machine learning and artificial intelligence that uses multi-layered neural networks to model and understand complex patterns in large data sets. I know this is a little bit confusing, but don't worry. As I said earlier, this is the main point. The red marked one here is the main point. So deep learning is inspired by the structure and functioning of the human brain. It involves networks with multiple layers, often referred as deep neural networks, that automatically extract and learn hierarchical representations of data. Right? So, yes, the definition is self explanatory. I need not to say, but just to tell you simply, deep learning is nothing but you have created an artificial neural network which resembles brain. Not only resembles, it exactly replicate the operations that are being happening in brain. Okay, that's what deep learning is all about. So on the right side here, the diagram, you can see a little animation over on the right side. So here we see this is a if you know a little bit about brain, biological functioning of brain, you will come to know that brain contains billions of neuron cells, and each of the neuron cells are interconnected with each other, passing information between them, right? So here also the same thing is happening. The dendrites we have here, they collect all the information as the input, and then the cell body here, they process the information, and then on the extreme right you can see the synaptic terminals which provides the output or the result to the next neuron or nerve cell. Okay, so this is the functioning of a biological neuron, right? In simple ways, I could also call it as natural neural network. So researchers wanted this to be artificial, so this is their aim, and they have come up with this artificial neural network on the right side. So here the input layer, whatever we have, so it takes up the information as the input, and then the hidden layer, it processes that in particular information, and then output layer, this will provide the result. Okay, so exactly whatever happening in natural neural network, the same operations are happening in this artificial neural network, correct? So and these rounded ones are called as nodes. So these are input nodes and hidden nodes and then output nodes. Hope you got how we have mimicked the natural biological weapon, I could say, the brain. So if we consider a single and simple neural network, you can see here x1 and x2 are input nodes which takes up the information, and then we have a hidden layer or a hidden node which you process that information, and then we have the output layer and the output node which provides the result, right? And what are these w1 and w2? Why are these passing from input 1 and input 2, or x1 and x2, right? So we'll learn that later, but for now this is a simple single neural network. Now we'll take a generalized example and explain our deep learning concept in a very simplified manner. So here if you see, in our day-to-day life, we usually cross the road many times in a day, right? When we cross the road, what are the two things that comes into our mind? The first one being if you see any vehicle approaching towards you or not, and the second is whether you can hear any sound, whether it might be a car honking sound or an engine sound near you. So these are the two inputs that based on which you take the decision whether to cross the road or not, right? Now for which one are you going to give more importance, whether it is a visual input or auditor input? So W1 is the importance that you give for input X1, and W2 is the importance that you give for input X2. Let us represent this example using a neural network. Okay. Here we have converted our example into a simple neural network. I have already shown you how a neural network looks like. It is quite similar to this, but you might find two major differences or two major additions here. The first one being the addition of B, and the second one is the presence of sigma and F in the hidden node. If you recall, the hidden node's purpose is to process the input, correct? So the processing here is happening by the weightage sum, which is sigma, and applying a function on it. So when you apply these two things on the input values, then we are going to get the output. Okay, that is why we have represented sigma and F in the hidden node for the processing identification. Now let's see this numerical calculations happening inside the neural network. So guys, now we'll discuss a numerical problem on this same example. Okay, I believe that solving a math problem will give you a complete idea of what is happening inside, whether it may be a deep learning or whether it may be transformers or whatever the artificial intelligence concept it is. If you know the math behind it, you will get a very good clarity over the subject. Okay, so here I'm going to show you um, a simple mathematical problem related to this particular example. Okay, then you will get a very good understanding over this topic. So I was telling you that this is how a simple neural network look like, right? We have two inputs, two weights associated with each of these inputs, and then we have a hidden layer which is for processing. And in the hidden layer, there is a weighted sum notation and function notation here. Then we have output. We have another term called as bias B. Okay, so I have already told you what sigma and function will do. So sigma is nothing but weighted sum, the sum of these two inputs with respect to the weights, and function is also something that we'll apply on the value that we get here in the weighted sum. Okay, okay, so just telling you might be confusing. I'll take you to that particular example itself, so that gives a better idea. Okay. Now, the thing is, I am representing this simple neural network problem into this form. Okay, I just split this hidden layer into two nodes. Okay, so for a better understanding, now I have a question for you. So, if I ask you as a human, uh, I'm again telling the same thing. Please don't worry about it. So, as a human, if we are crossing a road, then we'll take a decision based on the situations, right? Basically, here the car and the distance and all these factors will come into picture, right? So, this is the question I have. So, if the road is not clear and if you are hearing a car horn, then do we cross the road? No, right? So that's why zero here. And here also road is not clear, and then there is no car sound. So actually here the road is already not clear, so we will not cross at all. Correct? So here also zero. And then if you take this particular scenario, the road is clear, but you are hearing some car sound, then also we will not cross. Zero. Here, the last one, the road is clear and you are not hearing to any car sound from any of the direction. Then, in this particular example, you will cross the road. Okay. In the same way, if I ask you things like this, okay, let me show you that. Here, we have taken couple of another scenarios. and then we'll judge whether we need to cross the road or we just have to stay. Okay, so point 9, if the car is far away and you hear a slight car sound, yeah, since the car is far away, you are safe to cross the road, right? In the same way, we have kept all the possibilities, not all the possibilities, but some of the possibilities over here, and we have the output, right? This is a human intuition. uh, we already know that if these are the conditions, we won't do that, do not cross the road. Okay, but we already know this, these all things, but do you think the neural network whatever we are going to build knows all these things? No, right? For that reason, we have the same scenario over here. This is by neural network analysis. Okay, so if zero road not clear and zero car uh, on her, we will explicitly provide some values to it. Okay, so in this scenario I am telling the neural network to do not cross the road. Okay, just give the answer as do not cross the road. Here also same, zero, here also zero, and here it is one. Okay, so we have trained our neural network in this way, and then what we'll do next is we will ask the neural network to judge the output for all these conditions. Okay, here we have only 14, but what if you have 14,000, and what if you have 14 lakh, 14 million, or 14 billion? So the neural network, whatever it was trained on, it must be, the concept remains the same for it, and it applies to all of the scenarios we have, right? So now we are going to learn how can we train this neural network, and during training what internally is happening in the neural network is what we should know. That is what the numerical problem I was talking about. So if you know that, you will completely know about this learning concept. Okay, okay, all right. Now, so before anything, we already know about the inputs, right? These are the inputs. These are the inputs x1 and x2. Okay, but we do not know what are these weights. So we'll have to assume these weights in the first iteration. Okay, assume the weights and bias. This is the first thing we have to do. Okay, and then we will have to create a line equation for this scenario. Okay, so why we are going to create a line equation, we are going to cover that shortly. Okay, so looking at this picture you'll get the complete idea. Just stay tuned. So before we calculate the in output, we have to calculate the weighted sum, right? This we have already discussed. As you can see in this picture, first we have to calculate the weighted sum, and then we have to apply the function on it. Then we'll be calculating the output, right? So we are at this point, weighted sum. Okay, so z equal to w1 x1 plus w2 x2 plus b. This is how we will calculate the weighted sum. Now let me calculate for the four scenarios we have. Okay, firstly z equal to, for the first scenario, 0 and 0. Okay, 0 and 0, the sum will be z equal to w1 is 1, 1 into 0 0, plus again 1 into 0 0, minus 1.5 is the bias we have taken, so this will be 1.5, right? Minus 1.5. And the second scenario is, what is the second scenario we have? 0 0 0 1 1 0 1 1, right? So next is 0, 1. So here also the same thing. First 0, 1, right? 0 into 1 becomes 0 and 1 into 1 becomes 1 and this will be minus 1.5. So totally it will be minus 0.5, correct? And the third scenario is 1 comma 0 and 1 and 0. X1 is 1 and the next one is 0, right? So here 1 into 1, 1 plus 0 into 1, 0 minus 1.5. This again becomes minus 0.5. And the last scenario is 1 comma 1. So z equal to 1 into 1, 1 plus 1 into 1, 1 minus 1.5. This becomes 2 minus 1.5 is 0.5. So we are getting a positive value here. Rest or negative values. Okay. So the neural network, what it will do, by these values, it will draw a diagram from this weighted sum equation itself. So here the line equation becomes so first let me tell you this is the line equation z1 w1 x1 plus w2 x2 plus b. Okay, our main aim is to create the decision boundary. So in that case we'll have to keep z equal to 0. Okay, because we'll have to create a line and x1 and x2 are variables and w1 w2 and b are constant values, right? So w1 is 1, we already know, we already assumed w1 as 1, w2 as 1, so 1 into x2 and the bias is minus 1.5. So the line equation now becomes x1 plus x2 equal to 1.5. This is the line equation we have now. Okay, so the neural network now it will draw this particular line over here. Okay, and this line is called as the decision boundary, or this line is can also be called as a binary classifier. Okay, because no matter how many scenarios you give to this neural network now, whether it may be 14 or 14,000 or 14 million or 14 billion, whatever it may be, whatever the data points that are falling behind this line, below this line, they will be classified as class 0, and whatever the data points that fall above this line, these data points are part of class 1. Okay, so this line is successfully creating a boundary between two classes. That's why we are called it as decision boundary and also binary classifier. Okay, this is how the neural network is going to learn. Okay, that's the reason neural networks works very much faster than human intelligence or human reflexes. Okay, now you understood the thing, right? So what this neural network, I'll just tell you simply what we have discussed so far. So neural network, what it has to do is it will be creating a line internally in the vector space. It will be creating a line which separates the two classes. We have only two possibilities, right? Whether to cross the road or whether to not cross the road. So it creates a line and then it divides the line. It divides the classes into two types, one above and one below. Okay, so these kind of problems are called as linearly separable problems. So if we build a neural network which can divide the two classes, class 0 and class 1, on the basis of a single line, then those kind of problems are called as linearly separable problems. Okay, Yeah, this is what I thought of saying. Nothing more to discuss on this linearly separable topic. Okay, I'll just give you the overall what we have done. So as we already know what kind of decision we have to take, because our brain is ready made, it makes the decisions and do. Okay, and then neural network, as it is a machine, it doesn't know what it has to do. So first we have to train the neural network by giving some output values, or these if we write a code, these are called as the expected outputs. Okay, so we'll train this neural network, and then we'll give it thousands of scenarios or thousands of operations and combinations, and based on its training, now the neural network has to judge the output. Okay, so these are the type of problems which we called as linearly separable problems. Okay, so in real world, how are we using this linearly separable problems? Okay, let me show that as well. So here in our scenario, it is cross and don't cross, and then we get spam emails and have positive, negative, and approve, reject, buy, sell, whatever may be the scenario. Linearly separable problems are going to solve them. Okay, this is one thing, but actually, unfortunately, 95% of all real time problems are not linearly separable problems. Okay, then what are they? 95% of all these problems are non-linearly separable problems. So you cannot create a, I mean, not you, the neural network cannot create a linear equation or a line and separate classes into types. Okay, so this is what we are going to discuss now. We have successfully completed one scenario. Now we'll have to look at the other scenario, which is very important. Okay, so before we discuss the non-linear separable problem, let me show you, or let me execute the code on linearly separable problem, and let me show you how the neural network learns and gets trained, how it increases the accuracy and all. Okay, so yeah, I have written a code for this. So you don't get worried about it, or don't be scared, because all these things you are going to learn in our course. As you know, our course is going to teach you from the scratch. So even if you don't know Python, statistics, maths, or machine learning, you need not to worry about that. So everything will be taught here. First we'll have to import all the libraries here, and then I won't be explaining all the code over here, because it might confuse you at this point. So I'll just tell you what is going here in this code on a high level. Okay, so then what we'll be doing is we are giving the values we first taken. Okay, input 0 0 0 1 1 0 and 1 1, and then what we are doing here is we are providing the expected output. So this is nothing but the training, indirectly this a training data set. Okay, and then what I'm doing is, after that I am giving some other values, like in this case I have shown you, right? We have some 14 million, or here we have only 14, but even if you give some 14 million inputs here, the neural network will perform in the same way. Okay, so we have given some of the inputs here, and then let me show you the result. Okay, so this is the result it has created. So it is trained well and good. So input it has taken and expected predicted is also one. So the testing accuracy is perfect. and then we have given some additional inputs to it to for testing purpose, and these are the values, and it is it is able to predict them also correctly. Okay, so here the predicted is 1.9 and 0.9 condition. Okay, so this is the graph. You already know what it is going to do. It is just creating a linearly separable boundary, and then deciding which part of the data point comes under this class 1 and which of the data points come under this class 0. Okay, so this graph is made on the testing data set itself. Okay, so you would have already got some very good information from this, but you don't worry about it, because there are many terms which you might not be knowing, some of them being epochs, activation functions, accuracy, training data set, and all these things, because you are going to learn all these things in a sequential manner in our advanced machine learning and generative AI course. Okay, okay, now we have successfully completed one type of problem, which is linearly separable problem, and now it is time for learning the non-linearly separable problem. Okay, don't worry, I'm not going deep into this at this point of time. I'll just show you how to deal with the non-linearly separable problems. I'll just give you a overview of it again. So this was the situation, right? So if the data points are uh, plotted in this manner, we can simply draw a line in between them and simply classify them. But what if the data points are in this manner? What are you going to do? May not be you. What the neural network is going to do? You can't draw a line like this, right? Like this, or like this, or like whatever. You can't divide these points in a perfect manner. Then what are we going to do is the question. Okay, then that is the time activation functions came into existence. Okay, so at first this is the non-linearly separable data, right? Data points, right? So we'll have to convert these data points into this manner in the vector space, so that we can simply draw a line in between them and decide which of them are belonging to which classes. Okay, so for doing this type of analysis, we will have to add a simple function in between the problem, which is activation function. Okay, so we have different types of activation functions, as you can see here. Not these are not limited to this. We have Leaky-Relu and some other as well. So when you introduce activation function into your neural network model, it is going to look after your non-linearly separable problems as well. So that is where we are going to use this activation function. So till this point, I think and I hope the concept is clear. So till now we have just covered the linearly separable problems. Then we'll have to introduce the topic on activation functions, feed forward propagation, back forward propagation, calculation of total loss, gradient descent, and all. And then overfitting and underfitting, etc., etc. So from next session onwards, it is going to be very much easy, because you already learned the foundation of deep learning. Okay, so you need not to worry about the next topics, at least related to deep learning. Okay, and into our course, we are even going to provide you the study material, exclusive study material. So once you have gone through the video, whether it is live or recorded, you can just go through the study material that we are going to provide. It provides all the information related to each and every slide, so you need not to search here and there for that. Okay, yeah, thank you so much for your time.